Okay, here is day 3 of volumes of solids, and we're going to learn a new method called the washer method. So, for the disk method, we drew a rectangle, and basically the rectangle was perpendicular to the axis where we were rotating, and then it was touching the axis that we were rotating around. And now, for the washer method, we're still going to be perpendicular, but we're not going to be attached. So when we sketch this, and the best I can sketch it here, you're going to see why it's called the washer method. So let's try to draw this sketch. So we have another rectangle. If you revolved it around the x-axis, so you would have kind of a matching rectangle down here. And then you would revolve, so this top part goes to that, the inside to here, revolve that around and around, and this around and this around. So even with my not very good drawing, I think you can tell why it's called the washer method, and that's basically because it has a hole in it. So instead of being a solid circle on the end, it's like a washer with the hole in the middle. So let's find the volume of this figure. Now in this case, this is just like our representative cylinder. You would have a whole bunch of cylinders that would all be added up, and this is like a representative one. So we have actual numbers here, so we can find this volume easily. So this is going to be basically the volume of this outer cylinder. So there's kind of like a big cylinder here minus the hole, which is the volume of the inner cylinder. So it's like you're taking a big cylinder and you're cutting out a little cylinder from the middle. So the volume of the outer cylinder, well, it's going to be pi r squared. The radius for the outer cylinder is going to be right there, which is going to be 8. So you're going to have pi times 8 squared times the width, or the height of the cylinder, which goes this way, and that's 2. And then minus pi r squared, but for the inner cylinder, our radius is just 3. That's the small cylinder hole that's inside, but the width is still 2. So we can kind of do some factoring and simplifying with this, and then you can kind of see where the formula comes from. Both of these have pi, so we can factor out pi, and then they both have a 2 in it. They're both going to have the same width, so we can kind of put the 2 on this side and factor it out also. And then you're going to have left then just the outer radius squared minus the inner radius squared. So if we look at the formula, we can see that's exactly what it is. Because of course that's one representative cylinder, then we're going to have infinitely many, add them all up, and that's going to become integration. So your capital R is your outer radius, and little r is your inner radius. So you have the outside radius and you have the inside radius. Or basically the inner radius is the hole you're cutting out. So let's go ahead and do an example. And we're going to basically take the same figure and then we're going to revolve it around different things, and we'll see the difference that it makes. So first let's revolve around the x-axis. So let's get a good drawing, and then on here I can kind of cheat. I'm going to copy it to use for my other problems. You can just redraw it each time you need it. So if we draw, the first thing we need to draw is our y equals 2x squared. Now let's make those a little closer together so I can fit it better. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we graph our parabola, if we're at 0, we get 0. If we plug in a 1 for x, we're going to get 2, which means I'll have a mirror image over here. If I plug in 2, I'm going to get 8, which means mirror image over here. So this would be my parabola. And then we're also bound by the line y equals 0, which is the x-axis, and the line x equals 2. So the region that we're talking about is this region right here, bound by that curve, the line x equals 2, and the x-axis. So let me real quick, let me move this, let me move these words out of the way, and then we'll real quick, let's group this and copy it. You can just make quick sketches for your other parts, but I'm going to go ahead and clone it. And then let's put those on this other page. Oh, there should be another one. Oh, there we go. Well, I lost one. There we go. Okay, so we have first around the y-axis. So first thing you should do is always draw your motion showing that's where I'm revolving. So I'm revolving around the y-axis. Well, for both of these methods, I need to be perpendicular to the y-axis. So I'm going to draw my rectangle perpendicular to the y-axis. Now, for this one, it's not touching the y-axis, which means that as I revolve it around, there's going to have to be a hole in the center of this. Basically, where that parabola is going to cut out a parabolic sort of shaped hole there. So this is going to be the washer method. So for the washer method, we need to find an outer radius and an inner radius. So the outer radius here is going to be the distance from the y-axis to the outside of where the shape is. Well, that's going to be a constant. That's going to be 2. The inner radius is going to be the distance from the y-axis to the bottom of the rectangle, if you think of it that way, or to the left side of the rectangle there. Well, that's going to be simply the function. So, but remember, our width here is delta y or dy, so everything has to be in terms of y. My function was given in terms of x. So I'm going to have to take that y equals 2x squared and solve it for x. So we divide by 2, square root both sides. Now remember, technically you get plus and minus the square root of y over 2, but since we're only dealing on the right hand side, the positive side, I just need the plus. So that means my inner radius is simply that function I just found. So my volume is going to be pretty simple. It's basically still just pi r squared. It's just pi integral. Well, everything's in terms of y. My width is delta y, so I'm going to go from 0 to 8 because that's the top of my region up there. 8 was the last point I put on there. 2, 8. And then I have outer radius squared minus inner radius squared, which is the square root of y over 2 squared dy. And that's it. And all we're doing on this, or in these examples, is setting them up. You could certainly square that, go ahead and get the answer to that integral, but right now we're mostly concerned with setting up. We've had lots of practice of doing, so now we want to set up. Okay, so let's move this next one down here so we have more room. And this one is supposed to be revolving around the x-axis. So for this example, we're going to revolve here around the x-axis. So we're going to draw our rectangle, representative rectangle, perpendicular to the axis of revolution. So that's right here. Well, this time the rectangle touches the axis. So this is just going to be the disk method, the one we've been doing. So here all we need is the volume equals pi r squared. And we're integrating, the width here is delta x, so we need the x values, so that's 0 to 2. And this time the height of the rectangle is just the function, which is 2x squared, and then it's radius squared, so it's 2x squared, whole thing squared, dx, and that's it. And obviously, again, you could go ahead and do that integration, but we're just setting them up this time. Okay, so on this next one, we're going to do about the line y equals 8. So let's draw in the line y equals 8. That would be up here, the horizontal line y equals 8, and this is what we're going to revolve around. So my rectangle for this is going to need to be perpendicular to the y-axis, so we have to go vertically. And then clearly it does not touch the y equals 8 line, so this is going to be the washer method. So for the washer method, I need an outer radius, and I need an inner radius. So the outer radius is if I go from the axis I'm revolving around all the way to the farthest point, which is right there. Well, that's a constant distance of 8. So the outer radius is going to be 8. If I want the inner radius is this distance from here to the top or bottom, whichever way you want to look at it, of this rectangle. That's this distance. That's the hole that's going to be getting cut out of this as this revolves around. Well, to get that distance, I want to take, and to get that, I'm going to have this entire distance all the way to here, and then I have to subtract the function value, which goes from here to here, and then that will leave me this red part, which is what I want, which is this distance, the radius inside. So that means my little r is going to be 8 minus the function, which is 2x squared. And that's going to be my inner radius. And that's the red in the picture. So now I'm going to do my volume, and it's still pi r squared. I just have to think big minus little. So pi goes outside. My width is delta x, so everything's in terms of x. So that's 0 to 2. And then I have big radius squared minus little radius squared dx. And there we go. It's all set up. So again, you could square all that, multiply that out, get your answer. Setting it up is the hard part. All right, let's do the last one. We're going to revolve this one around the line x equals 2. So that means we're revolving it around this line right here. So again, I need to draw my rectangle to be perpendicular. So my representative rectangle could be right there. And I'm revolving around this line, x equals 2. And so my rectangle touches the axis of revolution, so this is going to be the disk method. So volume is pi. My width here is delta y, so I use my y values. That's going to be 0 to 8. And then I want my radius, and that's what all I need, and then I can answer the question. So the radius means the height of the rectangle here. So here we have to think about the distance, and we're going from the y-axis. Everything's in terms of y. So we need this distance minus this distance to give me the height of that rectangle. And so that's going to be 2 minus the function. And we already solved for the function in the first problem. It was y over 2, square root of y over 2. So it's 2 minus that whole thing squared, because this entire thing is my radius. And then I have to square it, and then dy. And so that's what you would get for this problem, which we would just need the disk method. So we did a couple of you can see the difference in the washer method and the disk method. All of them require the rectangle perpendicular to the axis of revolution, and that's the key. If it touches the axis, it's a disk method. If it does not touch the axis, then that means there's a hole in it, and you got to do big radius minus squared minus little radius squared. So we have one more method to learn, and then we'll have learned all we need to know about volumes.